car was parked after the snow ended. And you see this coating of ice. Here, just snow, right? Well, we had freezing drizzle this morning. We had freezing rain and freezing drizzle. We're still below freezing. In fact, so far the highest temperature was around 26 degrees. And that's after the freezing rain ended, or freezing drizzle, technically. We did have some freezing rain this morning around 9 a.m. See, the side did not have any freezing rain. But if you look on the top, you actually see, I'm going to even show you on the ground here, right here, I'm touching the snow here, and it's covered in a crust of ice that was caused by the freezing drizzle and freezing rain. See, there are icicles hanging from the bottom of the cars because there was some freezing rain. See how they're streaking down? We're still way below freezing, and we had a freezing drizzle this morning, a little bit of freezing rain, which is first time I've seen this in quite a while. I have not seen, and also the lowest temperature I've ever seen, second lowest temperature I've ever seen freezing rain at. The lowest I've ever seen freezing rain at was, I think, 26 degrees, but this morning it was lower than that. It was 24. Why did we have freezing rain this morning, even though temperatures are so cold outside? Well, you see this stratus cover, this dark stratus. You know, though their winds are coming out of the southwest, so they're bringing in warm air aloft. However, winds there are coming out of the southwest, west-southwest. But look at the surface wind, right there, coming out of the southeast. Why is this happening? You know, you also think a southeast wind would bring in warm air, right? But this southeast wind has nothing to do with the weather system that's coming through. This southeast wind is because of the land breeze, because the lake is so warm, the air here at the surface is so cold that you're getting a land breeze that is bringing air towards the lake. Like yesterday morning, we had a northwest wind at the loft, but right near the surface we had a southeast wind, but we had lake effect snow showers on and off all day long yesterday here in Oswego. And I posted a video to Twitter showing that we were having snow flurries with no clouds overhead because the air was so cold that any little moisture was being immediately squeezed out. I'm looking towards the lake. There's little bits of ice out there, but like ice flows. Or those are white caps. No, those are ice flows right there. I don't know if you can see it. Do those white dots out there? Those are flows of ice. Ice that has broken off from the shore. The lake temperature is actually in the mid to upper 30s. Like yesterday, we were in the low 20s, and that was cold enough for lake effect snow. Tomorrow, the models are showing a little bit of lake effect. It only shows Oswego getting like an inch or so with light lake effect snow, though we are under a winter storm watch for the lake effect. Surprised it's not a lake effect snow warning, but a winter storm watch, which is a bit unusual considering this is not a winter storm that's going to be impacting the weather tomorrow. The storm is actually pulling away right now, but you see that southeast wind, even though the land's going to be much cooler than the lake, the flow from the northwest will be so strong that it's going to overwhelm that land breeze, and it's going to override it, and you're going to have a northwest flow at the surface as well, bringing gusty northwest winds with highs tomorrow failing to get above freezing like they are now. But the high temperature for today was forecast to be 37. But it doesn't feel like it's 37. It still feels like it's in the 20s. I'm actually going to check the current temperature right now. Still below freezing. Current temperature still below freezing. I am still running the live stream about the earthquake swarm in Greece. Actually, it's still drizzling a little. Yep, I just felt some drizzle. Yep. Okay, freezing drizzle again. This freezing drizzle is coming from the stratus layer. But keep in mind, at this layer, temperatures are above freezing. It's in the mid to upper 30s at that cloud layer. That's why we're getting liquid drizzle. But you would think, because of how cold it is at the surface, that the drizzle would quickly refreeze back into sleet or a frozen pebble. No. The cold layer is very shallow. Only, I would say, once you get it just a bit above the smokestack, it's going to be shooting to above freezing. We're at 29 here at the surface. I think not even 1,000 feet up, it's probably in the mid to upper 30s. So very shallow cold layer. And temperatures are forecast to get into the mid 30s. Because temperature has steadily warmed up from 24 degrees earlier. Now they're 29. Still below freezing, but we're inching closer towards the freezing mark, which would mean there will be some melting this afternoon. Probably not much. Your cars will probably still be coated with ice by the time the wind shifts and temperature starts crashing back down. But there will be some melting. So about the earthquake swarm in Greece, I am not concerned about it at all. I mean, not volcanically, but tectonically, yes, I'm a little concerned. But it could have been like what happened in 1956, where you had a magnitude 7.7, which killed many, many people because of the earthquake and the tsunami. People are saying that this is worse. It's more stressful. Yes, you're getting a lot of shaking. It's rattling a lot of nerves. But the worst, it could be so much worse. It could be so much worse because you could have, if it wasn't for this seismic slip, for the slow earthquake, for this continuous swarm, if all that seismic attention was released all at once, you could have had a pretty substantial earthquake, at least a magnitude 6 or 7 greater. So the fact that you're having this slow earthquake is actually good. I know it's, it was looking like briefly that this is volcanic activity, considering the proximity to Colombo. But no, this is likely, very likely, and it's now seeming even more likely now to be a slow seismic slip of the Amorgos, Andrios, or Santorini Amorgos seismic zone. So see ice right here? Freezing drizzle, freezing rain. But it's mostly over. Still a little drizzle coming down, but anyway, there was actually some uplift, some ground rise reported at Santorini, but there is a reason for that. Again, not volcanic, but tectonic. So Santorini is located on something called a footwall, while other areas are something called a hanging wall, which sinks. So a footwall actually goes up while the hanging wall goes down. So during a normal fault earthquake, because this is more like a graben, in a normal fault setting, in a normal fault tectonic setting, you have plate A, the hanging wall, moving up, while plate B, or this is not tectonic plates. These are not like ocean. These are not like the type of plates where you have. This is a seismic. So A would go up. Section A would go up. Section B would sink down. And believe it or not, normal fault earthquakes, if occurring underwater, could generate a tsunami. Also depends on how sharp the hanging wall is. Generate an tsunami comparable to a higher magnitude subduction earthquake. For instance, the magnitude 7.7 in 1956 generated a 30-meter high tsunami, which for a 7.7 earthquake is extremely high. This was not because of landslides. This was because of something. Because one of the segment, the hanging wall, the foot wall, went up by a great amount. With a subduction zone, you would get a snapward motion, like a snap, as the tectonic plate that's subducting underneath would rupture, but then a rupture, the oceanic plate is subducting under, so it unstuck, but you get a bit of a rebound. You get a rebound of the continental crust that was being forced down, like the edge of it, by the subducting oceanic plate. And then, so it, snaps back to its original position, and that snapward upward, that's that release that as it goes a little bit up, the continental crust generates the earthquake, because this is actual like whole plates that are moving. With the Amorgos fault, it's sections of plate, not the whole plate. You're not getting motion of like an entire plate subducting. You're getting small sections of it, like you're getting, like you might get an earthquake in New Jersey on an ancient fault line, something like this. So one fault, one part of the fault goes up, another goes down, but with normal faulting, the upward motion is much more significant than with subduction. Hence, greater tsunamis, despite a similar or even smaller magnitude earthquake than with a true subduction earthquake. So worse tsunamis, despite earthquake being under magnitude 8. If the 1956 Amorgos earthquake was greater than a magnitude 8, tsunami might have been even higher. It might have been, if let's say it was a magnitude 8.5, it could have been 40-meter tsunami. If it was a subduction earthquake, and it was a 7.7, you might have gotten a 20, 30 foot wave, not a 30-meter wave. Thank you. At worst, the wave might have been 20, 30 feet, but most likely you probably would have just gotten maybe a 10, 15 foot wave. Keep in mind the 9.1 Tohoku earthquake in 2011 generated waves of near 100 feet, but those were the highest. You had a 9.1. You've had subduction earthquakes that are 7.7 or 8.0 that generated small tsunamis, especially if they're deeper. So that means this was likely a surface rupture too that caused the Amorgos plate to rupture in 756. Again, let's talk about the weather again. Models are also showing a winter storm for Oswego in upstate New York. Saturday night through early Sunday morning, only bringing about 4 to 6 inches. Lake effect event for tomorrow, models are showing about 1 to 3 inches, with 4 to 7 inches possible in eastern Oswego County and the higher elevations around the Tug Hill Plateau, especially east central Oswego County. Anyway, the plate that I'm describing, the Amorgos plate, is currently having what is called a slow slip event. And it's not continuous. Like, you'll get little pauses in activity, then it would pick up again. That's why you would be getting, looking at the Marathonas seismometer, you would get pulses of earthquake activity, what looks like some, but if you're looking at Thera, you're getting almost like what looks like a continuous earthquake. That's because, or continuous tremor, that's because the plate is continuously moving right now. It's moving, it's having a constant earthquake. What? Fire system. Oh, great. Fire system check. Fire system safety check. Oh, man. Oh. Just they didn't find. All right, let's see. All right. Yeah, I gotta go right now. Just uh, thank you so much. Bye.